to my channel. My name is PrachiSharma, and in today's session we are working on all the observations and equations for the chapters Nitric Acid and Sulphuric Acid. The similar video for ammonia and HCl was already uploaded some time back, and this video was pending. So today we are working on observations and equations of these two chapters, that is Nitric Acid and Sulphuric Acid. Plus, we'll be looking at a few observation questions as to what to expect in the examination. So without wasting any time, let's get started. Alright students, so let's get started with this session. I hope the screen is clearly visible to you. So for nitric acid, we do have about two pages. So this is the first page. And then, let me zoom out. So we have two pages for nitric acid. Then we have one page for sulfuric acid. And then we have some questions. So that will be the sequence of this session. If you have any specific preference, you can jump on to that portion. So let's start with nitric acid. So I only have equations and observation in this. So if there is anything else in detail you want to study, there is already a mind map video for nitric acid and sulfuric acid separately. So you can go ahead and check that out. So let's get started with the session today. Now first is nitric acid lab preparation. So for lab preparation, either you can use potassium nitrate or sodium nitrate. Both the conditions have to be maintained below 200 degrees Celsius. And what is the reason for that? The reason is that your your nitric acid gets decomposed. So to avoid that, the temperature has to be maintained below 200 degrees Celsius. So let's look at the equations. So KNO3 plus H2SO4 below 200 degrees Celsius gives you KHSO4 plus HNO3. Either they can ask you the reactants, they can ask you the products, they can also ask you the conditions for this particular reaction as well as the reason for this condition. So any of those questions can be asked. Next is thermal decomposition of nitric acid. So what is thermal decomposition? You take nitric acid, provide heat to it, and it breaks down into its constituent products. So that is what is happening. So you have HNO3 that is breaking down into water, nitrogen dioxide and oxygen. So you should have a heat symbol right here. So let me quickly make that. Okay. Next is manufacture of nitric acid by Oswald's process. So this is the industrial manufacturing of nitric acid. So it is important for you to understand this particular concept. This happens in various steps. Step 1 is catalytic oxidation of ammonia. In this case, what happens is that you have ammonia, you provide oxygen to it. So that will break down to NO. Okay, so I hope that makes sense. So you have catalytic oxidation of ammonia. And why do we call it catalytic oxidation? Because it happens in the presence of a catalyst. So this is a catalytic oxidation of ammonia. Alright. So for NH3, that is ammonia, plus oxygen in the presence of platinum at 800 degrees Celsius gives you 4NO plus water plus heat comes out. The second step is oxidation of nitric oxide. So the nitric oxide that you have got, you have to oxidize that by providing more oxygen. So this happens at the temperature of 50 degrees Celsius and it gives you NO2. Step 3, absorption of nitrogen dioxide. NO2 plus 2H2O gives you O2 plus HNO3. So now you see that HNO3 is formed at this stage. Now oxidizing properties. Nitric acid is a good oxidizing agent because it gives you nascent oxygen. Okay, so you have C plus HNO3 gives you carbon dioxide, water plus nitrogen dioxide. If they ask you why do we use HNO3 as an oxidizing agent or what does it perform as an oxidizing agent, so the main reason is the presence of nascent oxygen in it, which ends up oxidizing any element provided with it. So the first case was for carbon, the second is for sulfur. So sulfur plus 6HNO3 gives you H2SO4 plus water plus NO2. Now we have some properties which are starting from right here. Pure nitric acid is colorless. This is an observation question. Pure nitric acid is colorless, but in lab we get a yellowish color due to the presence of nitrogen dioxide gas. Now, a lot of students ask me that, ma'am, is it just nitrogen dioxide combined in the acid? So the answer is no. When we leave the acid out, the acid has a tendency to absorb different gases from the atmosphere. Nitrogen dioxide specifically ends up giving it a yellowish color. So that is the reason we specifically talk about this gas. Now this gas color can be removed. It can be removed by two methods. So remove yellow color by two methods. First is either you add carbon dioxide. The other is you add water. When you are adding carbon dioxide, it dries out NO2. When you add water, it dissolves NO2 in itself. So two different methods and two different things happening. When we have carbon dioxide, it will drive out CO2. When you have water, it dissolves NO2. Okay. Now, after that, you have the next is very dilute. Alright, so this was the first one. Okay, now let's come back on here. This is action on metals. So first is cold and dilute nitric acid. So when you have cold and dilute nitric acid, you have equations, only three equations for that. So the first is copper reacting with HNO3, giving you CuNO3 whole twice plus water plus NO. Now students, I have told this like a million times by now. This equation is extremely important, and along with this equation is extremely important. You have to understand the difference between these two equations, and not just these two, but the same thing is happening for zinc and iron also. But you have to understand the difference between here. Copper, when it reacts with cold and dilute HNO3, gives you NO. When copper reacts with concentrated nitric acid, it gives you NO2. This question can be asked in multiple ways. Either they can ask you, write an equation for copper reacting with cold and dilute nitric acid. Simple. They can ask you what gas is released when copper reacts with concentrated nitric acid. They can also ask you, identify the gas which you get when copper is reacting with concentrated nitric acid. Another type of question can be, they give you fill in the blank. That means copper plus HNO3, actually not HNO3, they'll give you copper. On the product side, they'll give you NO2 and let's say CuNO3 whole twice. So you need to make sure that when you mention HNO3 in that blank, you write it is concentrated HNO3. So that is how they can ask you the same information in multiple formats. So this particular equation is extremely important, and even this year I am expecting that this equation will be asked in the examination. So let's move ahead to the next part. Next is metals like iron, aluminium, cobalt and nickel. So what happens with these particular metals? When these metals end up reacting with HNO3, they form a thin layer over itself. For example, if you're talking about iron, iron oxide will be deposited as a thin layer and it will cover up the metal. Due to this, the direct contact between iron and HNO3 is cut out. And since this direct contact is cut out, the reaction does not carry out. Okay, so the reaction stops right there. So what do we say here? Due to formation of extremely thin layer of metallic oxide, which stops the reaction. So they do not further go into the reaction. This question can also be asked in multiple ways. They can ask you, write an equation for iron and aluminium, or what will you observe when iron reacts with HNO3. So you should know the content, okay? You should know what will happen. Let's move ahead to the D part, that is very dilute HNO3. That is just 1% HNO3. Now when you have just 1% HNO3, it only reacts with two metals, that is magnesium and manganese. Only two metals. And in these two metals, it gives you hydrogen gas. Okay, so I hope you understand by now. When you have HNO3 cold and dilute, you end up getting NO as a constituent gas. When it is concentrated, you end up getting NO2. When it is extremely dilute, only 1% of gas, and it is reacting with the metal directly, manganese or magnesium, then you get hydrogen gas along with the corresponding nitrate. Okay, I hope this much is clear to you. Let's move ahead to the note. Dilute HNO3 is generally considered a typical acid except for its reactions with metals Therefore, it gives oxides instead of hydrogen. Okay, I hope that makes sense to you. Let's move to the next page. Now, nitric acid. Tests for nitric acid. The most important test for nitric acid is the brown ring test. So let's look at it. Nitrates other than sodium, potassium, ammonium produce reddish brown fumes of nitrogen dioxide. Okay, so I hope you remember, you have to remember these exceptions. Nitrates other than sodium, potassium, ammonium produce reddish brown fumes of nitrogen dioxide. Now the second test is brown ring test. So you have FeSO4 plus H2SO4 plus HNO3. These three reactants are there. Once you react this, you get Fe2SO4 whole thrice plus water plus NO. This Fe2SO4 whole thrice, this has to be freshly prepared. So once that happens, you get FeSO4 plus NO, that gives you FeSO4.NO. Okay, this is the compound responsible for the brown ring that is generated at the junction of the liquids. So this is the main compound responsible for that, and this is also known as nitrosoferrous sulfate. This question can be asked in multiple ways. They can ask you, name the compound responsible for the brown ring formation at the junction of the liquids. Nitrosoferrous sulfate. They can say, identify the element. So you will have different elements written, the different compound names written, and on the other side you will have brown ring or NO3 test. So that is a nitrate test. So anything can be written. So you have to match and understand that that is nitrosoferrous sulfate responsible for the formation of brown ring. Now let's move ahead. Effect of heat on nitrates. Sodium and potassium nitrates or alkali metal nitrates. So when you provide heat to these particular alkali metals, you get oxygen. Okay, so NaNO2, provide heat to it, you get NaNO2 plus oxygen. Then KNO3 gives you KNO2 plus oxygen. Now second is all nitrates except mercury and silver. Okay, nitrate will give you oxide plus NO2 plus oxygen. Three different things are coming out. And this is possible for all nitrates except mercury and silver. Then what does silver and mercury do? When you have silver and mercury, you get the metal, NO2 and oxygen. Okay. Next is ammonium nitrate. Ammonium nitrate specifically will give you N2O, that is nitrous oxide. And along with that you get water. And this nitrous oxide is also known as laughing gas. Let's quickly revise the last portion. Okay, when you have sodium potassium nitrates, they will give you NaNO2 or KNO2 plus oxygen. Okay, sodium or potassium nitrate, you get the nitrate itself and you get oxygen. Second, all nitrates except silver and mercury will give you NO2. They will first give you oxide of that particular nitrate. So oxide plus NO2 plus oxygen. Okay. Third, when you have silver and mercury will give you the metal, NO2 plus oxygen. Okay. Last portion, ammonium nitrate. Ammonium nitrate will give you N2O, which is also known as laughing gas, and water. This is also known as nitrous oxide. Now, a lot of students ask me which are the most important ones in this one. So the most important ones are your silver and mercury and ammonium nitrate. Okay, but that does not mean you don't learn the other two, but these are the most repetitive questions I have seen. Let's move ahead to the next one. Sulphuric acid. Okay, manufacture of sulphuric acid is by contact process. So this is your industrial preparation of sulphuric acid. So let's look at the different methods. The first is production of sulfur dioxide. This is step 1. So you have iron pyrites, that is FeS, plus 11O2 giving you Fe2O3 plus 8SO2. Either you can learn this equation, or if you just write S plus O2 gives you SO2, that is also acceptable, because the main reason is you need SO2. So you can produce it in different ways. Either you use it by iron pyrites method or this method. Okay. In the second method, you are using pure sulfur. Okay, 99.9% pure sulfur. Second step, catalytic oxidation of sulfur dioxide. Once you have sulfur dioxide, you add oxygen to it, in the presence of vanadium pentoxide at 450 degrees Celsius, and this will give you SO3. This is sulfur trioxide. So what are we doing? First step, sulfur plus oxygen gives SO2. Second step, SO2 plus oxygen gives SO3. Now third step, absorption of sulfur trioxide in sulfuric acid. So you have SO3 plus H2SO4. This gives you oleum. What is oleum? Oleum is H2S2O7. Fifth, dilution of oleum to obtain sulfuric acid. You have oleum, add water to it, you get sulfuric acid. Okay, let's quickly revise. S plus O2 gives SO2, step 1. Step 2, in SO2 add oxygen in the presence of vanadium pentoxide at 450 degrees Celsius, you get oleum. Take oleum, no, you don't get oleum, you get SO3, sulfur trioxide. Take sulfur trioxide, add H2SO4 to it, you get oleum. Once you have oleum, add water to oleum, you get sulfuric acid. Now, how can they ask you this question? Sometimes they will ask the entire process and different steps. Okay. But these days, since the entire process and details are not in the syllabus, the way they are asking questions in the sample papers is that they'll ask you, write the equations from contact process from the absorption of sulfur trioxide till the gain of sulfuric acid. So you need to write two equations, that is your sulfur trioxide right here, adding sulfuric acid and getting oleum, and then taking oleum and adding water to it and giving you sulfuric acid. So you need to understand the steps, because it's not necessary that they will ask you all the steps. They may ask you just two equations or just one equation. Now let's move ahead. Now we have properties of sulfuric acid. The first property is acidic property, and in this case we are talking about dilute acid. So you have magnesium, zinc, iron plus H2SO4 gives you MgSO4 plus hydrogen. This is a typical acid property. Important thing to understand here is, like for example, nitric acid. The majority of questions that form from nitric acid are based upon whether nitric acid was concentrated or dilute, and what kind of component it was reacting with, and what kind of products you were getting. That means sometimes you are getting NO2, sometimes you are getting N2O. Depending on situation, what are you getting? Those were the type of questions we get for nitric acid, very common. Now what kind of questions do we get from sulfuric acid? In sulfuric acid, majority of the questions will come from properties. Okay, they will give you an equation and they will ask you what kind of property is sulfuric acid showing here. Okay, so either it will be showing acidic property, that is your typical acidic property, either it will be showing dehydrating property or volatile nature. Okay, so these are the type of questions you get from sulfuric acid. The reason I am helping you understand these things is so that you prepare the chapter accordingly. For nitric acid, focus on equation, what products you are getting, learn the products. For sulfuric acid, learn the different type of properties and identify the reaction. Okay, for each property you should at least learn one reaction. Other than that, majorly they give you the reaction and ask you to identify the type of property. So looking at the reaction, you should know what is happening. That's it. Okay, so let's look at the first part, acidic property. Magnesium, zinc, iron reacting with H2SO4 gives you MgSO4 plus hydrogen. Then next is CuO plus FeO. This is nothing but metallic oxides. When you have metallic oxides, you get sulfate plus water. Okay, so how to remember this? When you have just metal, you get hydrogen. You get metallic oxide, hydrogen becomes water. Okay, when you get hydroxides, the same thing stays. Whether you get oxide or hydroxide, the hydrogen has just become water. So that's it. Next is you have metallic carbonates. So you get carbon dioxide along with water. Then again hydrogen carbonates, along with water you get carbon dioxide. Again that is the same thing happening here. Now you have sulfates, you get H2S. Sorry, sulfides, you get H2S, that is hydrogen sulfide. Rotten egg smelling gas, that will be your observation in this case. ZNS, again H2S. Now you have Na2SO3. Okay, in that case you get SO2, sulfur dioxide. So this is how you can remember the pattern. Let's move to the second part, concentrated acid. Okay, so the first part was if you get any of these equations and they ask you to identify, you will say this is a typical acid property. That's what you would say. Typical acid property, any acid will behave like this only. When you move to the second part, concentrated acid. In this case, you have different formats. The first is non-volatile nature. So the non-volatile nature means this particular acid is used in the manufacture of other acids. Okay, that is, you have learned the preparation of HCl, you use H2SO4. In the preparation of nitric acid, you use H2SO4. So this means that when it is a non-volatile means that so volatile means that it vaporizes when you leave it in atmosphere. Non-volatile means is that it won't vaporize and the reaction will successfully complete. So that is what this nature means. Whenever you see an equation in which you have an acid formed in the products because of H2SO4, that is non-volatile nature of concentrated acid. If you want to learn the equation, just write any lab preparation, either write for HCl or HNO3, which one you are more comfortable with. So let's look at that. NaCl plus H2SO4 giving us NaHSO4 plus HCl. Then KCl plus H2SO4, KHSO4 plus HCl. And the same thing is happening. You have nitric acid. Now this one is new. That is CH3COONA plus H2SO4 giving you NaHSO4 plus acetic acid. So this one, these last two you can learn depending on your choice. Sorry, not this one. The last one is nitric acid again. Now, from this side, we are moving on to the left side. As an oxidizing agent, H2SO4 is giving you nascent oxygen. If you see, H2SO4 is decomposing, giving you water plus SO2 plus nascent oxygen. Now, how is it oxidizing copper and sulfur? So, C plus H2SO4 giving you CO2 plus water plus SO2. And same thing is happening for sulfur and copper. Okay, so make sure that you understand what is happening when the equation comes in front of you. Now imagine these equations are mixed together and you look at an equation. Will you be able to identify the property or not? Practice that. Now next is removes water of crystallization. So CuSO4 dot 5H2O gives you CuSO4 dot 5H2O. Sorry, plus 5H2O. This is the only example for water of crystallization, so there is no confusion with this one. Next is C6H12O6 in the presence of concentrated sulfuric acid gives you 6C plus 6H2O. This is sugar. This is reaction of sulfuric acid with sugar. Another observation question. What they can ask you is that what will happen when you have sugar and concentrated sulfuric acid is dropped in it. So what happens is that it becomes very blackish and a black mass is created. Okay. So that is how sugar is reacted, and that black mass is made of carbon. That is carbon. Okay, and these two equations are important. So C6H12O6 gives you 6C plus water, and this 6C that you see, this particular compound is blackish in color. That is deposited at the bottom of the apparatus. Now the same thing is happening in the second one. C12H22O11 concentrated sulfuric acid. 12C plus H2O. Okay, so this is what the equations are. Last is test for sulfuric acid. This is the most common one. So what happens in this case is that you have BaCl2, that is barium chloride, reacting with H2SO4 giving you BaSO4 dot 2HCl. This BaSO4 is a white PPT. Okay, that is what the test is about. When you react sulfuric acid with barium chloride, you get BaSO4, which is a white precipitate insoluble in all mineral acids. Okay, so that is what this test is. So reacting sulfuric acid with barium chloride gives you BaSO4, that is a white PPT insoluble in all mineral acids. A common question I have seen for this test is that they will ask you, you have H2SO4 and HCl, both of them are colorless, and both of them are reacting with barium chloride. How will you differentiate between them? So for barium chloride, for H2SO4, this is what you will write, that it is getting a white PPT insoluble in all mineral acids. For HCl, you will say for HCl, barium chloride does not show any reaction. So no observation happens. This is the difference between the two. Alright students, let's quickly move ahead to the questions. So the first question is, what do you observe when nitric acid is kept in a reagent bottle? So that will give you a yellowish brown color. It turns yellowish brown. The second question is, nitric acid is dropped over heated sawdust. In this case, the heated sawdust will catch fire. Third question is, nitrogen dioxide is passed through acidified, freshly prepared ferrous sulfate solution. So this solution turns brown black. That is your observation. Fourth, concentrated sulfuric acid is slowly added from the sides of the test tube containing a solution of nitrate, an equal volume of freshly prepared ferrous sulfate solution. So in this case, a brown ring appears at the junction of the two liquids. This is your observation. Moving ahead to the last question for nitric acid. What do you observe when copper is added to concentrated nitric acid? So what happens is, the pinkish red metal, that is your copper, it dissolves to give a bluish or greenish blue solution with the liberation of a reddish brown colored gas which has a pungent suffocating smell. That will be your observation. If you want, I can repeat it. Pinkish red metal, that is copper, dissolves to give you a greenish blue solution, and a reddish brown gas is liberated which has a pungent suffocating smell. That is your observation. Let's move to question number 2. These questions are based on sulfuric acid. Sugar crystals are added to a hard glass test tube containing concentrated sulfuric acid. So sugar chars. Chars means creates a blackish compound or black porous mass. So that is what would happen. The second is, when crystals of CuSO4.5H2O is placed in concentrated sulfuric acid. So in this case, the water of crystallization is lost. That means when the blue color crystals crumble down to form a white powder, because it removes the water of crystallization from the compound. Now the next is dilute sulfuric acid with magnesium. So when you have just magnesium, you get a gas which burns with a pop sound. When you have dilute sulfuric acid reacting with iron sulfide, you get a gas which has a rotten egg smelling gas, that is your hydrogen sulfide gas. So that will be your observation. So these are the basic questions for observations for these two particular chapters. Alright students, so this is it for today's session, and I hope I was able to address all the concerns about these two chapters and specifically about the equations and observations. If there is any particular question that you are struggling with and you would like my help, please don't hesitate to drop a comment in the comment box and I will definitely respond back. So thank you so much, and we'll catch up in the next session.